continuation of Group 3's report. So now let's discuss about crossbreeding and genetic engineering produce new varieties of crops and livestock. Crossbreeding through artificial selection is being used by farmers and scientists for centuries to develop genetically improved varieties of crops and livestock animals. Crossbreeding would take 15 years or more to produce a variety of new crops. Scientists are creating a second gene revolution by using genetic engineering. Genetic engineering is being used to develop genetically modified strains of crops and livestock animals. Gene splicing is a process to alter an organism's genetic material through adding, deleting, or changing segments of its DNA. The goal of gene splicing is to add desirable traits or to eliminate undesirable ones by enabling scientists to transfer genes between different species that would not normally breed in nature. The resulting organisms are called genetically modified organisms or GMOs. Bioengineers hope to develop new GMO varieties of crop that are resistant to heat, cold, drought, insect pests, parasites, viral diseases, herbicides, and salty or acidic soil. So now let's move on to meat consumption has grown steadily. Meat and animal products such as eggs and milk are sources of high-quality protein and represent the world's second major food-producing system. Figure 10.5 shows industrialized beef production. On this cattle feedlot in West Texas, thousands of cattle are fathered on grain for a few months before being slaughtered. Figure 10.6 shows concentrated chicken feeding operation in Iowa, USA. Such operations can house up to 100,000 chickens. Now let's proceed to fish production and shellfish production have risen dramatically. Fisheries and aquaculture is the world's third major food producing system. Fishery is a concentration of particular aquatic species suitable for commercial harvesting in a given ocean area or inland body of water. Aquaculture or fish farming is the practice of raising fish in freshwater ponds, lakes, reservoirs, and rice paddies, and in underwater cages in coastal and deeper ocean waters. Figure 10.7 shows world seafood production, including both wild catch, marine and inland, and aquaculture grow between 1950 and 2012, with the wild catch generally leveling off since 1996 and aquaculture production rising sharply since 1990. Industrialized food production requires huge inputs of energy. The industrialization of food production has been made possibly by using fossil fuels, mostly oil and natural gas, to run farm machinery and fishing vessels, to pump irrigation water for crops, and to produce synthetic pesticides and synthetic inorganic fertilizers. Producing food has major environmental impacts. Industrialized agriculture has allowed farmers to use less land to produce more food, and this has helped to protect biodiversity in many areas by reducing the destruction of forests and grasslands for farming. Many analysts point out that industrialized agriculture has greater overall harmful environmental impacts that shows in figure 10.8 than any other human activity that these environmental effects may limit future food production. Next is topsoil erosion is a serious problem in parts of the world. Soil is literally the foundation of life on land. Topsoil is the fertile top layer of many soils. Topsoil is a vital component of natural capital. Irreplaceable topsoil is one of the Earth's most important renewable resources. Topsoil renewal is one of the Earth's most important ecosystem services. Lastly, I will be discussing to you about natural capital degradation. Soil erosion is one major problem related to agriculture. Figure 10.9 shows flowing water, the largest cause of erosion, carries away particles of topsoil that have been loosened by rainfall. In figure 10.10, severe erosion of this type leads to the formation of gullies. Erosion of topsoil has three major harmful effects. First, loss of soil fertility through depletion of plant nutrients in topsoil. Second, water pollution. Third, erosion releases carbon that was stored in the soil by vegetation into the air and water. Soil pollution is also a problem in parts of the world. Some of the chemicals emitted into the atmosphere by industrial and power plants and by motor vehicles can pollute soil and water used to irrigate soil. Pesticides can also contaminate soil. Next topic will be discussed by my group mate Anariza.
Thank you, Miss Adria. So now let us move on to the next topic that I will be going to discuss, which is the soil is the foundation of life on land. Soil is a complex mixture of eroded rock, mineral nutrients, decaying organic matter, water, air, and billions of living organisms, most of them microscopic decomposers. Soil formation begins when bedrock is slowly broken down into fragments and particles by physical, chemical, and biological processes called weathering. Figure 10.A shows profiles of different aged soils. Organisms living in the soil remove carbon dioxide from the atmosphere and store it as organic carbon compounds, thereby helping to control the Earth's climate as part of the carbon cycle. Most soils that have developed over long periods of time, called mature soils, contain horizontal layers or horizons, each with a distinct texture and composition that vary with different types of soils. The spaces or pores between the solid organic and inorganic particles in the upper and lower soil layers contain varying amounts of air, mostly nitrogen and oxygen gas and water. Although topsoil is a renewable resource, it is renewed very slowly, which means it can be depleted. Just 1 centimeter or equivalent to 0.4 inch of topsoil can take hundreds of years to form, but it can be washed or blown away in a matter of weeks or months when we plow grassland or clear a forest and leave its topsoil unprotected. Next is drought, and human activities are degrading dry lands. A major threat to food security in some of the world's water-short dry lands, which are home for some 2 billion people, is desertification. It is the process in which the productive potential of topsoil falls by 10% or more because of a combination of prolonged drought and human activities that expose topsoil to erosion. Desertification can be moderate, with a 10 to 25% drop in productivity, and can be severe with a drop of 25 to 50%, or very severe with a drop of more than 50%, usually resulting in large gullies and sand dunes, as seen in figure 10.12. Next is excessive irrigation has serious consequences. A major reason for the success of farmers in boosting productivity on farms is the use of irrigation, which accounts for about 70% of the water that humanity uses. However, irrigation has a downside. Most irrigation water is a dilute solution of various salts, such as sodium chloride, that are picked up as the water flows over or through soil and rocks. Repeated applications of irrigation water in dry climates led to the gradual accumulation of salts in the upper soil layers. A soil degradation process called soil salinization. It stunts crop growth, lowers crop yields, and can eventually kill plants and ruin the land. Salinization affects almost one-fourth of irrigated cropland in the United States, especially in western states, as seen in figure 10.13. Another problem with irrigation is waterlogging. Waterlogging lowers the productivity of crop plants and kills them after prolonged exposure because it deprives plants of the oxygen they need to survive. Next is agriculture contributes to air pollution and climate change. Agricultural activities including the clearing and burning of forests to raise crops or livestock create a great deal of air pollution. According to the 2006 FAO study, livestock's long shadow industrialized livestock production generates about 18% of the world's greenhouse gases, more than all of the world's cars, trucks, and buses and planes emit. Next is food and biofuel production systems have caused major losses of biodiversity. Natural biodiversity and some ecosystem services are threatened when tropical and other forests are cleared and when grasslands are plowed up and replaced with croplands used to produce food and biofuels. A related problem is the increasing loss of agrobiodiversity, the genetic variety of animal and plant species used on farms to produce food. In losing agrobiodiversity, ecologists warn that we are rapidly shrinking the world's genetic library of plant varieties, which are critical for increasing food yields. The world's most secure seed bank is the underground Doomsday Seed Vault, which was carved into the Arctic permafrost on a frozen Norwegian Arctic island, as seen in figure 10.14. It is being stocked with duplicates of much of the world's seed collections. Next topic is there is controversy over genetically engineered foods. While genetic engineering could help to improve food security for some, controversy has arisen over the use of this technology. Its producers and investors see genetically modified food production as a potentially sustainable way to solve world hunger problems. Some critics recognize the potential benefits of GM crops, as shown in figure 10.15, but they point out that most of the GM crops developed so far have provided very few of these benefits.
Now let's proceed to the other topic, which is the limits to expansion of the green revolutions. So far, several factors have limited the success of the green revolutions and may limit them even more in the future. For example, without large inputs of water and synthetic and organic fertilizer and pesticides, most green revolution and genetically engineered crop varieties produce yields that are no higher and are sometimes lower than those from traditional strains. Scientists point out that where such inputs do increase yields, there comes a point where yields stop growing because of the inability of crop plants to take up nutrients from additional fertilizer and irrigation water. Can we expand the green revolution by irrigating more cropland? Since 1978, the amount of irrigated land per person has been declining, and it is projected to fall much more by 2050. Other factors are limited availability of irrigation water, soil salinization, and the fact that most of the world's farmers do not have enough money to irrigate their crops. In addition, projected climate change during this country is likely to melt some of the mountain glaciers that provide irrigation and drinking water for many millions of people in the China, India, and South America. Can we increase the food supply by cultivating more land? We have already cleared or converted about 38% of the world's ice-free land
surface for use as cropland and pastures. The problem is that such massive clearing of forests would speed up climate change and increase topsoil erosion and biodiversity losses. Next topic is industrialized meat production has harmful environmental effects. Proponents of industrialized meat production point out that it has increased meat supplies, reduced overgrazing, and keep food prices down. But feed, according to the figure 10.5 and concentrated animal feeding operation that shows in figure 10.6, use large amounts of water to grow feed for livestock and to wash away their wastes. In his book, The Food Revolution, John Robbins estimated that you'd save more water by not eating a pound of California beef than you would by not showering for a year. Analysts also point out that meat produced by industrialized agriculture is artificially cheap because most of its harmful environmental and health costs are not included in the market prices of meat and meat products. A violation of the full cost pricing, figure 10.16, summarizes the advantages and disadvantages of industrialized meat production. Next topic is meat production and ocean dead zones. Huge amount of synthetic and organic fertilizer are used in the Midwestern United States to produce corn for animal feed and ethanol fuel for cars. Much of these fertilizers runs off cropland and eventually goes into the Mississippi River. Each year, this creates a dead zone often larger than the United States of Massachusetts. This oxygen-depleted zone threatens 1/5 of the nation's seafood yield. In other words, growing corn in the Midwest largely to feed cattle and fuel cars degrades aquatic biodiversity and seafood production in the Gulf of Mexico. Industrialized meat production uses large amount of energy, mostly from oil, which helps to make it one of the chief source of air and water pollution and greenhouse gas emissions. The Environmental Working Group has estimated that production of meat and meat products generate 10 to 20 times more greenhouse gases per unit of weight than those production of common vegetables and grains. Another growing problem is the use of antibiotics. In industrialized livestock production facilities, according to the FDA data and several studies, this plays a role in the rise of genetic resistance among many disease-causing bacteria. Next topic is aquaculture can harm aquatic ecosystem. Each used in figure 10.17 lists the major benefits and drawbacks of aquaculture, which in 2012 accounted for about 42% of all seafood produced for human consumption. Some analysts warn that the harmful environmental effects of aquaculture could limit its future production potential. One major environmental problem associated with aquaculture is that about a third of the wild fish caught from the oceans are used to make the fish meal and fish oil that are fed to farm fish. This is contributing to the depleting of many populations of wild fish that are crucial to marine food webs, a serious threat to marine biodiversity and ecosystem services. Another problem is that some fish meal and fish oil feed to farm-raised fish is contaminated with long-lived toxins such as PCBs and dioxins that are picked up from the ocean floor. Next topic is nature controls the populations of most pests.
A pest is any species that interferes with human welfare by competing with us for food, invading our homes, lawns, or gardens, destroying building materials, spreading disease, invading ecosystem, or simply being a nuisance in natural ecosystem and in many polyculture crop field. Natural enemies or predators, parasites, and disease organisms control the population of most potential species. This free ecosystem service is an important part of the Earth's natural capital. Most spiders, including the wolf spider, which shows in figure 10.18, do not harm humans. Next topic is synthetic pesticides provide several benefits. Use of synthetic pesticides has its advantages and disadvantages. Proponents contend that the benefits of pesticides, which shows in figure 10.19 left, outweigh their harmful effects. Figure 10.19 right, they point to the following benefits. First is they have saved human lives. Second, they can increase food supplies by reducing food losses due to pests. Third, they can help farmers to increase their profits. They work fast. When used properly, the health risks of some pesticides are very low relative to their benefits according to some scientific studies. Newer pesticides are safer to use.
Let's now move on to synthetic pesticides have several drawbacks. They have several side problems. They accelerate the development of genetic resistance to pesticide in pest organisms. They can put farmers in a financial treadmills. Pesticides are usually applied inefficiently and often pollute the environment. Some insecticides kill natural predators and parasites that helps to control the pest populations. Pesticides are usually applied inefficiently and often pollute the environment. Some pesticides harm wildlife. Some pesticides threaten human health. In figure 10.20, individuals matter. You can reduce the exposure to pesticides. Next is the ecological surprises, the law of unintended consequences. Then unexpected things began to happen. The Deltron also killed other insects, including flies and cockroaches, living in houses, which made the islanders happy. Next, small insect-eating lizards living in the house died after arguing themselves and Deltron contaminated insects. Pesticide use has not consequently reduced U.S. crop losses the pest, largely because of genetic resistance and loss of many natural predators. Synthetic pesticides have not always succeeded in producing U.S. crop losses. And David Brementhal, an expert in insect ecology, evaluated data from more than 300 agricultural scientists and economists. He reached three major conclusions. First, between 1942 and 1997, estimated crop losses from insect almost doubled from 7% to 13%, despite a tenfold increase in the use of synthetic insecticides. Second, according to the International Food Policy Research Institute, the estimated environmental health and social costs of pesticide use in the United States are $5 to $10 in damages for every dollar spent on pesticides. Third, experience indicates that alternative pest management practices could cut the use of synthetic pesticides by half on 40 major U.S. crops without reducing crop yields. Next, laws and treaties can help to protect us from the harmful effect of pesticides. Food
Food Quality Protection Act, mostly because of growing scientific evidence and citizen pressure concerning the effect of small amounts of pesticides on children. Pesticides and food choices. According to the Environmental Working Group, EWG, a research organization that helped to push through the Food Quality Protection Act, you could reduce your pesticide intake up to 90% by eating only 100% USDA certified organic version of 12 types of fruits and vegetables that tend to have the highest pesticide reduces. Next, there are alternatives to synthetic pesticides. Fool the pest. Provide home for pest enemies. Implant genetic resistance. Bring in natural enemies. Use insect perfumes. Bring in the hormones. Reduce the use of synthetic herbicides to control weeds. In Figure 10.21, Natural Capital, in this example of biological pest control, a wasp in parasitizing a gypsy moth caterpillar. Integrated pest management is a component of more sustainable agriculture. The overall aim of IPM is to reduce the crop damage to an economically tolerable level. Integrated pest management. A growing number of scientists are arguing the USDA to use the 3-point strategy to promote IPM in the United States. To continue the discussion, here is April Rose.
Thank you, Ms. Rapon. To continue the report, first is the use government policies to improve food production and security. Agriculture is a financially risky business. Whether farmers have a good or bad year depends on factors over which they have little control, including weather, crop prices, pests and diseases, interest rates on loans, and global food markets. Government use two main approaches to influence food production. First, they can control food prices by putting a legally mandated limit on them in order to keep them artificially low. Second, they can provide subsidies by giving farmers price supports, tax breaks, the other financial support to help them stay in business and to encourage them to increase food production. Next is the other government and private programs are increasing food security. Studies by the United Nations Children's Fund or UNICEF indicate that 1/2 to 2/3 of nutrition-related childhood deaths to prevent at an average annual cost of $5 to $10 per child. To prevent the annual cost of the nutrition-related childhood deaths, this would involve simple measures such as immunizing more children against childhood diseases. Sustainable agriculturists and National Geographic emerging explorers Sid Simonis and Paula Segura worked with small farmers to show them how to grow food more sustainably on small plots in the tropical forests of Brazil. Next is we can grow and buy more food locally and cut food waste. One way to increase food security is to grow more of our food locally or regionally, ideally with certified organic farming practices. A growing number of consumers are becoming locavores and buying more of their food from local and regional producers in farmers' markets. An increase in demand for locally grown food could result in more small, diversified farms that produce organic, minimally processed food from plants and animals. Food columnist Mark Britman estimated that converting 10% of Americans' lawns into food-producing gardens would supply 1/3 of the country's fresh produce. Many urban schools, colleges, and universities are benefiting greatly from having gardens on school grounds. Not only do the students have a ready source of fresh produce, but they also learn about where their food comes from and how to grow their own food more sustainably. Finally, people can sharply cut food waste as an important component of improving food security. See Concept 10.5. Next is many farmers are reducing soil erosion. Land used for food production must have fertile topsoil, see Figure 10.a, which takes hundreds of years to form. On this steeply sloped land, contour planting, Figure 10.22b, can be used to reduce topsoil erosion. Similarly, strip cropping, Figure 10.22b, helps to reduce erosion and to restore soil fertility with alternating strips of a row crop, such as corn or cotton, and another crop that completely covers the soil, called a cover crop, or such as alfalfa, clover, oats, or rye. Alley cropping or agroforestry, Figure 10.22c, is another way to slow the erosion of topsoil and to maintain soil fertility. One or more crops, usually legumes or other crops that add nitrogen to the soil, are planted together in alleys between orchard trees or fruit-bearing shrubs, which provide shade. This reduces water loss by evaporation and helps retain and slowly release soil moisture. Such conservation tillage farming uses special tillers and planting machines that inject seeds and fertilizer directly through crop residues into minimally disturbed topsoil. This type of farming increases crop yields and greatly reduces soil erosion and water pollution from sediment and fertilizer runoff. Lastly, we can restore soil fertility. The best way to maintain soil fertility is through topsoil conservation, especially through methods that keep topsoil covered with vegetation, Figure 10.22. The best option is to restore some of the lost plant nutrients that have been washed, blown, or leached out of topsoil or that have been removed by repeated crop harvesting. There are several types of organic fertilizers. One is animal manure, the dung and urine of cattle, horses, poultry, Figure 10.23, and other farm animals. Another type is called green manure. Consists of freshly cut or growing green vegetation that is plowed into the topsoil to increase the organic matter and humus available to the next crop. The third type is compost. It produced when microorganisms break down organic matter such as leaves, crop residues, food waste, paper, and wood in the presence of oxygen. That would be all, and the last discussion will be discussed by Ms. Corativo.
Thank you, Ms. Iso. Now let's proceed to we can reduce soil salinization and desertification. Reducing desertification is not easy. We cannot control the timing and location of prolonged droughts caused by changes in weather and climate patterns. We can also work to decrease the human contribution to projected climate change, which could increase the severity of droughts in larger areas of the world during this century. It is possible to restore land suffering from desertification by planting trees and other plants that anchor topsoil and hold water. Some producers practice more sustainable aquaculture. One approach is open ocean aquaculture, which involves raising large carnivorous fish in underwater pens, some as large as high school gymnasium. Other fish farmers are reducing coastal damage from aquaculture by raising shrimp and fish species in inland facilities using zero discharge freshwater ponds and tanks. In the long run, Making aquaculture more sustainable will require some fundamental changes for producers and consumers. One change is for more customers to choose fish species that eat algae and other vegetation rather than other fish. Aquaculture producers can avoid this problem by raising plant-eating fishes such as carp, tilapia, and catfish as long as they do not try to increase yield by feeding fish meal to such species as many as them are doing. Fish farmers can also emphasize poly-aquaculture, which has been part of aquaculture for centuries, especially in Southeast Asia. Poly-aquaculture operations raise fish or shrimp along with algae, seaweeds, and shellfish in costals, ponds, and tanks. The waste of the fish or shrimp feed the other species. We can produce meat and dairy products more efficiently. Meat production has a huge environmental impact, and meat consumption is the largest factor in the growing ecological footprints in individuals in affluent nations. A more sustainable form of meat production and consumption would involve shifting from less green efficient forms of animal proteins such as beef, pork, and carnivorous fish produced by aquaculture to more grain efficient forms such as poultry and plant-eating farm. We could also shift from buying chicken that has been raised in CAFUs in figure 10.6, which produce large amount of manure that is not returned to the soil, to supporting free-range chickens operation that use chicken manure to fertilize the soil in figure 10.23. We can make a shift to more sustainable food production. Scientific principle of sustainability, it relies heavily on the use of fossil fuel and thus adds greenhouse gases and other air pollutants to the atmosphere and contributes to climate change. It also reduces biodiversity and agrobiodiversity and interferes with the cycling of plant nutrients. Figure 10.8 are not included in the market price of food, a violation of the full cost pricing principle of sustainability. Many experts support a shift to organic farming because it sharply reduces the harmful environment and health effects of industrialized farming. Analysts suggest 5 major strategies to help farmers and consumers to make the transition to more sustainable agriculture over the 50 years. First, greatly increase research on more sustainable organic farming and funeral polyculture and on improving human nutrition. Second, establish education and training. Third, set up international fund to give farmers in poor countries access to various types of more sustainable agriculture. Fourth, replace government subsidies for environmental harmful form of industrialized food production with subsidies that encourage more sustainable food production. And fifth, mount of a massive program to educate consumers about where their food really comes from, how it is produced, and what are the harmful environmental and health effects of industrialized food production. Next is perennial polyculture and the Land Institute. Perennial crops which live from several years help farmers copy nature by better using and conserving natural resources, sunlight, soil, and water. Perennial crops also remove and store more carbon from the atmosphere, and growing them requires less energy than thus growing annual crops in conventional monocultures. Finally, the transition to more sustainable food production would be accelerated for the benefit of the environment as well as current and future generation if we could find ways to include the harmful environmental and health costs of food production in the market prices of food, in keeping with all three social science principles of sustainability.
Thank you for listening, and that would be all.